Hi everyone, today we're going to go through some example problems of different types of variation. So yesterday in class we talked about direct variation and inverse variation, and we sort of went through the basics. I'll review them here as well, and we're going to go through some example problems. We're also going to talk about joint variation and combined variation. So let's just do a quick review. Yesterday when we were talking about variation, we said when you are dealing with direct variation, we would use the equation y is equal to k times x, where k is our constant of variation. Constant of variation. And so if I'm trying to solve for k, right, if I just divide both sides by x, then I end up with y over x. That's how I would solve for k. With inverse variation, we said we would end up, the equation would look a little bit different. Instead of k times x, it's k over x. And we said with inverse variation, as one value increases, the other one decreases. So if you were solving this for k, you would multiply both sides by x. So you would have k is equal to x times y. And so when you're given a table of values, you can determine whether or not you have direct or inverse variation simply by calculating k, which I'll talk about in a little bit. Let's go through a few example problems and how you would attack them when you're dealing with, when you have word problems. So the first important bit of information is that it tells you right in the problem what kind of variation it is. They would have to tell you that, otherwise you wouldn't be able to do the problem. So in this one, it says the circumference of a circle varies directly as the radius. And they gave you the circumference when the radius is 3.5. Okay, so it says it varies directly. Because it varies directly, I'm using y is equal to k times x. Now, in this case, I don't have y and I don't have x. I have circumference and I have radius. So circumference is 7 pi when r is 3.5. C would be our y value because the c depends on the r. Okay, so my circumference, 7 pi, is going to equal k times 3.5. And so the first thing I have to do is I have to solve for k. So I'm going to divide both sides by 3.5. And I'll solve for k. In my calculator then, I've got, let's see, 7, let me clear this out, 7 pi. If you do the second and then the caret key, that gives you pi, divided by 3.5. And that gives you your constant of variation. It's about 6.28. And so now it says, now find r with this new c value. Okay, so now I'm doing c is equal to k times r. I know what my c is, 4.5 pi. I know what my k value is. I just found that out, 6.82. And I'm trying to find r. So you have to find k first. In all of these problems, you have to find k first before you can do the second part of the problem. And now it's just straightforward. You're just dividing both sides by 6.82. And we'll figure out what r is then. 4.5 pi divided by 6.8. Oops, sorry, 0.28, not 82, 28. I wrote that wrong. So r comes out to be about 2.25, 2.25 feet. This should have been 2.8, not 8.2 here. I transposed the numbers from the calculator. That should have been 2.8, and over here it should have been 2.8. Okay, so that's how you would go about solving a direct variation problem. Very straightforward. With all of these problems, first thing you're going to do is find that k value. Find k first and then plug that in to find your missing variable. Our next problem is inverse variation. Again, we're doing the same process. We're solving for k first, and then we're using that in our second equation. So with all of these problems, we're always doing two equations. Here they're telling you it varies inversely. So they're telling you right in the problem. So I know that I have to use inverse variation, so I have y is equal to k over x. Now, again, I'm not using y and I'm not using x. I have these other variables, but that's okay. It says the time it takes for a group of volunteers to construct a house varies inversely as the number of volunteers. So t is dependent on v, right? So t is our y value. So I have t is equal to k over v. It says if 20 volunteers can build a house in 62.5 working hours. 62.5 is equal to k over 20. So now I'm just going to solve for k. 62.5 times 20. So I end up with k is equal to 1250. The second part then says how many volunteers would be needed to build a house in 50 working hours. Okay, so now I still have the same equation, t equals k over v, but now I have k and I have t. My new t is 50, so now I'm going to solve for v. So I have, let's see, 50 is equal to 1250 over v. Now, if you cross multiply here, right, or if you multiply both sides by v, you can think of it that way. Here my v's cancel, so I'm left with 50v is equal to 1250. And then I'm just dividing both sides by 50. And when I do that, I end up with 25. So in that case, I would need 25 volunteers. So this really should make sense, right? Because we said as one variable increases, the other one is going to decrease. The number of hours decreased. It went from 62.5 down to 50, but the number of volunteers increased. I started at 20 and I'm now up to 25. Okay, so as one variable increases, the other one has to decrease with inverse variation. Okay, let's talk about two other types of variation. The first one here is joint variation. And it's not really any different than what we've done. It just has another component to it. It tells you in the problem if it's joint variation. Okay? When you see joint variation, all that is 3 variables instead of 2 variables. So instead of y is equal to kx, it's y is equal to kxz. So there's just another variable in there. Okay, but it's still direct variation. It's just with an added variable in there. Okay, so this says the area of a triangle varies jointly as the base and the height. So the area of a triangle varies jointly as the base and the height. Okay, it says when A is 12, B is 6, and H is 4. So I have 12 is equal to 24k. So k, if I divide both sides by 24, is 0.5. So now in the second part here, it says to find b. So I'm still using the same equation. A is equal to k times b times h. But now A is 36. I know that k is 0.5. I just figured that out. I'm trying to find b, and I know that h is 8. Okay, so if I divide both sides by 0.5, that gives me 72 is equal to b b times 8, and then if I divide both sides by 8, I end up with b is equal to 9, and that would be meters. And I didn't do it in the last problem, but make sure you label. Whenever you're dealing with word problems, you want to make sure you put a label in there. Okay, the last one, so that was joint variation. Like I said, you're just adding another variable in there, okay? The last one is combined variation. And combined variation is just putting inverse variation together with direct variation in the same problem, okay? So you'll see in this problem here, you've got inverse variation and direct variation. Okay, so we're going to put that all into one problem. And it's not that hard to do. It's just a matter of kind of figuring out how you're going to go about setting it up. Okay, so we've got the volume V of a gas varies inversely as the pressure P and directly as the temperature T. So I've got the volume of gas, volume V of gas, varies inversely, so I still have K, varies inversely as the pressure, so that has to go in the denominator, but directly as the temperature, so that goes in the numerator. Okay, so I literally went just step by step, word by word, to create my equation. It says that it has a volume of 10, a temperature of 300, let's see, and a pressure of 1.5. So we're going to solve for K. That's going to be the first thing we do. So if I multiply both sides by 1.5, I end up with 15 is equal to 300 K, and divide both sides by 300. 15 divided by 300 would be 0.05, so that's my K value. Now we can go on to the second part. It says now that the volume is 7.5, and the temp, we know what K is, that's 0.05, because again, we're still using this formula. Okay, so I know that K is 0.05. I know that the temperature is 350, and I'm trying to find out what this new pressure is. So again, I'm going to multiply both sides by P, so that we'll cancel that out. So I have 7.5 P is equal to 0.05 times 350. So that would be 17.5. And then to solve for P, we just divide both sides by 7.5. And we get about 2.3, and the pressure is in atmospheres, and that label is ATM. Okay, so that is how we are going to do all of these different types of problems. Remember, just take it step by step, set up your equation, solve for K, and then use that same equation again with that value for K to solve for the missing variable. It's the same process over and over again. It just depends on whether it's direct, inverse, joint, or combined, which equation you're going to use. Hopefully that helps. I'll see you guys next time. Take care, everybody.